Hey guys, welcome to what will be the last lessons of this unit. Two topics, average value and accumulation, which is not really a new topic, but I'm going to do some more with it. So average value is pretty much one formula, but there's another term we use, average rate of change, which sounds so similar that it's important to distinguish between the two because they ask both questions. You'll be asked both questions, both on my test and the AP test, and you have to know which of these things to use when you're asked which. So the average of a bunch of things is you add them up and divide by the number of things you added. So for the average value of a function, I'm going to add a bunch of function values and divide by the number of function values I added. I add up 20 values, I got to divide by 20. So we know now when we're talking about adding up a bunch of things, we can use this symbol, which is a sigma. We usually have some index I that starts somewhere and ends somewhere else. Again, I mentioned the number 20, but this could be any number. If I want to find the average value of a bunch of functions, I should add up a bunch of function values. So this is the sum of the first n function values of that, whatever, I choose whatever they are, right? Think about this like Riemann sums, like these would be the heights of the rectangles. But then to find the average of these, I want to divide this whole thing by n. Because n is the number of things I added up. So this is probably better written like this. So this is like the way that this is normally written. I add n things. This is like dividing by n. Then I'm going to do some manipulation. I want you guys to remember that two things. One, if I have a function, we did this, A from A to B, and it looks like whatever. Like we often divided this thing up into a bunch of like rectangles like this, right? And then to figure out this distance, which we often call delta x, you take the difference between A and B and you divide by the number of rectangles you divided up into. I showed some people this formula, not everybody needed it, but it's like candy. It's like this is B minus A is the distance here, n is the number of pieces I divided it up into. So delta x is B minus A over n. So I bring that up because I'm going to do a little manipulation here. First thing I'm going to do is I'm going to put that 1 over n I had on the outside, I'm going to put it on the inside, which I can do because the only things I can't move around here are things that have i's in them because that's part of the function, but it's not part of the function here. Put the n on the bottom here, that's 1 over n. The reason I put it on the bottom is because I'm going to multiply this thing by b minus a, this whole expression, and I'm going to divide it by b minus a. This is multiplying, this is dividing. And like we just saw, this thing here is delta x. So and this little thing I just ended up writing right here, this is like a Riemann sum for f of x with n and with n subintervals. So we turn that thing into an integral by taking a limit as n approaches infinity. So when we might say I can move to the front because there's no n's in it, right? It's not, nothing about that is changing. And this limit, the limit n approaches infinity of this expression is the integral from a to b of f of x dx. That's like the actual definition of the integral, is just that limit of that Riemann sum. So what we've discovered is that this expression up here, which is where we started, we just wrote the average value. We did a little manipulation here to get the b minus a's in there. And then the limit, when we take the limit, we get that this function, the limit as n approaches infinity of this average equals this. What that means is that instead of adding up like 10 or 20 or 30 function values and taking the average, we're adding up literally every function value and taking the average. So average value of a function, 1 over b minus a times the integral from a to b of f of x dx. So We look at this. The integral from a to b of f of x gives us the signed area right between the graph, between the graph and the x-axis. My question is, what do I get if I, so this is the integral from a to b. What if I get if I divide, like basically I'm like, what do I get if I divide that by the length of the interval? Be like a to b. What do I get if I divide that by the length? The answer is there's some area here. There's some area here. I want that to be red. There's some area here. Call that area A. And like, basically this average value is like, if I drew a rectangle that had the same area, like the green and the red areas are equal. A rectangle with the same area as a red one, then the height of that thing would be 1 over b minus a times the integral from a to b of x dx. Basically gives us the height of a height of a rectangle with area equal to the integral from a to b of x dx. So I don't know, that may not be that helpful of a thing to know, but this is the important part of this lesson. Let's try to find the average value. I'm going to do it right now. So, find the average value of cosine on this interval. Well, the average value of function is 1 over b minus a times the integral from a to b of f of x. Oh, there's f of x. Oh. Average value is 1 over, or b, and there's a. So 5 minus -3 plus 3 times the integral from -3 to 5 cosine x dx. That's 1 over 8. Antiderivative of cosine is sine, evaluated from 5 to -3. Those are kind of stupid numbers for sine, but whatever. Sine of 5 minus the sine of -3. And then that's like a number you plug in your calculator. You can leave it like that. I got about -0.102 when I put in my calculator. That's fine. And this is this next thing is kind of the vitally important part of this. Average value of cosine x means you use this formula that we just learned. Average rate of change is an average rate of change. This is like a slope. This is always going to be f of b minus f of a over b minus a. We've actually seen this many times before. But like, I cannot express enough. I cannot overestimate how important it is to know the difference between the two things, because they're getting at totally different answers when you do these things. The average rate of change of cosine x would be cosine of b, which is 5, minus cosine of -3 over 5 plus 3 again. So that's another thing you plug in your calculator if you wanted to, and you get 0.159. Like, I'm just saying, you have to be able to distinguish between average value and average rate of change, because they're just not the same thing, period. So that's how average value works, just like this every time. The thing that can make this more difficult is the antiderivative could be more difficult than the one that I gave you. This one is cosine, the antiderivative of that is sine. It's just a formula, you just know that one. I can make this more complicated. But other than that, average, it says find the average value of a function, that's this expression, 1 over b minus a. It says find the average rate of change, that's the slope. It's different, they're different things. slope, integral, slope, integral. Okay. So I'm going to do a couple examples. I'll do a couple examples of this and a couple examples of like what I mean by accumulation. We'll talk a little bit about velocity acceleration in the next video. So stay tuned.